The big picture for this lesson is piecewise functions. A piecewise function is basically a function that is not continuous. And what that means is it's not a smooth transition throughout the function. There might be a place where the function skips, like you can see here. You skip from y equals -5 up to y equals 0. And then notice you have a horizontal segment, and then it skips again. It might look like a set of stairs, kind of. That's called a step function. They really could look like anything, and this lesson actually does a pretty good job of explaining a piecewise function in context. I would definitely suggest you pay close attention to that. Just going to analyze this piecewise function here. When you're looking at a piecewise function, first thing you want to do is you want to kind of figure out what the pieces are. So for example, this piece down at the bottom, it looks like it's y equals, and the rate of change is 1, so it's going to be x, and then -5. So in function notation, it is going to be like this. Okay, and the next piece is just a horizontal line, and that's just 0, basically. The outputs are all 0, so f of x equals 0 is the next piece. And the next piece, it looks like, let's see, the rate of change is 1, but it stops right here. What I like to do is I like to just kind of continue the line, and then that'll help show what the y-intercept is. So if I were to take this line and continue it down through, it looks like it intersects right there. See, at y equals 1. So that means this equation is x plus 1. So the rate of change is 1. So f of x equals x plus 1. Okay, so those are the three pieces of functions. And then the next thing you do is you need to look at the domains. So for this first domain, the x minus 5, that domain is less than 0. So the interval that we're going to use is x is less than 0. And this next one, f of x equals 0, well, that's between x equals 0 and 3, and it's closed on both ends because 0 and 3 are both included. So this one is going to be like that. X is between 0 and 3 and including 0 and 3. The last piece is for x greater than 3 because you go to the right. See, open circle not including 3, but everything greater than 3. So x is greater than 3. So that is essentially how to write a piecewise function given the different pieces. You need to figure out what each piece represents and then figure out the domains after. Okay, so typically when you're writing a piecewise function, you're just going to write it as 1 f of x. So in other words, you will get rid of all this. And you would just say, with a big bracket right here, f x equals, like that. So f of x equals all that. Okay, now what if you want to evaluate the function? Like what if you want to find f of 4, let's say? Well, the first thing you need to do is figure out which piece the function uses. And since we have a graph, we can use that, but you can also use these intervals that are given for the different pieces of the function. So f of x equals 4 is over here, so I'm going to go up, and it looks like it intersects at 5 for y. So f of 4 equals 5. Well, let's look at the equation perspective. What you want to do is you want to look at these intervals and then check the inequalities and see if 4 satisfies any of the inequalities. So 0 greater than 4? Nope, that's not true. Is 4 between 0 and 3? No, but 4 is greater than 3. So that tells you that you're going to use this piece right here, the x plus 1. So you get f of 4 equals 4 plus 1, which is 5. Okay, so that's the big picture for this lesson. There's a lot in this lesson, including step functions and greatest integer functions. And I would really encourage you to make sure you watch all the videos, Take really good notes because there is a lot of stuff here.